Hello everyone, welcome to this session on time response analysis in control systems. In this video, we will understand how systems respond over time and why this concept is important in real-world applications. So before discussing this topic, let's recall the last class session. In last class session, we discussed about the signal flow graph. In this, the signal flow graph is how important for analyzing the critical control systems and advantages, disadvantages of the signal flow graph. And today's topics for discussion is Introduction to Time Response Analysis, Transient and Steady State Response, Standard Test Signals and Performance Specifications and Time Response Analysis. Why this topic is important? Now let us empathize the design thinking phase. In real-world electrical systems, we often encountered problems like oscillations in power system voltage, unstable motor control, and slow response in protection systems. If these issues are not analyzed properly, they can lead to system instability, equipment damage, and poor performance. So, impact if not solved means it gives the poor performance in many real-world critical applications. So, let's move on to the need for the solutions. Some limitations of existing methods are simplified models ignore nonlinearities, frequency domain analysis lacks of time insights, and manual calculations for complex systems. So, we need advanced tools like real-time analysis tools and AI-based prediction method tools, and we required advanced simulation software for this solution. So next move on to the defined part of Introduction to Time Response Analysis. The definition is time response analysis is the study of how systems output changes over time when an input is applied. It helps us understand system behavior and evaluate stability and design better controllers. And also it describes dynamic behavior of systems and reveals the performance characteristics of the system. So in this, the R of S we declared as an input and C of S is the response or we called it as an output, and the gain is G of S and the feedback signal is H of S. So we can get the time response analysis M of S is equal to G of S by 1 plus G of S into H of S. In this, the components which are used for time response analysis is transient response. It gives the initial behavior of the system. Steady state response, it gives the long-term behavior of the system. So we can calculate the total response is equal to transient plus steady state response. It shows the transient response of the system. So in this, transient response represents how the system transitions from initial to final state. So it is temporary in nature and help us to determine stability, settling time, that means the speed of response, and it determines the stability of the system. So let's mathematical representation of transient response is C of t is equal to C of suffix t plus C of s into t. So here the small t represents the transient response and the smallest represents the steady state error response. Now let us see the steady state response of the control system. So steady state response represents the system behavior as time approaches infinity. It is the permanent part of the response and help us to measure the accuracy and steady state error of the system. A good system should have minimum steady state error. Now let us see the standard test signals in time response analysis. So the standard test signals are step signal, impulse signal, ramp signal and parabolic signal. So this is used to analyze the system behavior and these inputs help us to evaluate how systems react under different conditions. The step signal is represented as R of t is equal to A into U of t. In x-axis we represent the time response and the y-axis we represent the step signal response. And this is the impulse signal. It is noted as R of t is equal to A into del of t. And the ramp signal is noted as the R of t is equal to A into t into U of t. And the parabolic signal is R of t is equal to A into t square into U of t. Now let us see the performance specifications in time response analysis. The first one is a rise time. It is represented as t of r. And it gives the speed of response. And the rise time is from 10% to 90% of its final value. Next one is the peak time. It gives the time to reach the maximum value, and or we call it as in time to reach the first peak of overshoot. So this one is the time peak time TP. And the next one is a settling time, a time to reach and stay within plus or minus 2% or plus or minus 5% of its final value. And the overshoot, that is MP, maximum overshoot, the maximum exceedance of final value. Steady state error, that is represented as ESS, difference between the desired and actual output at the time tends to infinity. Now let's move on to the applications of time response analysis. In control systems, it is used for PID controllers tuning, servo motors design, stability analysis. And if we come to the power system analysis, it gives the voltage regulation, load frequency control and transient stability. We go for electronic circuits for stability analysis and oscillator circuits and amplifier circuits. And this is the activity for this topic. And let's summarize this topic based on the discussion. Through activities like role play, we can understand design trade-offs such as rise time versus settling time, overshoot considerations. And time response analysis help us to understand, analyze and improve the system performance. Thank you.